Hello everyone, welcome to Job Conquest. In this video, let us learn about machine learning interview questions for freshers. First question, explain the difference between classification and regression. Classification in machine learning refers to a type of supervised learning task where the goal is to predict the category or class that an input belongs to based on historical data. Each input is assigned to one of several predefined classes, which are typically discrete labels. Regression in machine learning is a type of supervised learning task where the goal is to predict a continuous value based on input data. Unlike classification, where the output is a discrete label or class, regression aims to predict a numerical value. The predicted value can be any real number, example, price, temperature, or time. What does bias in machine learning refer to? Bias in data indicates the presence of inconsistencies within the data. The inconsistency might rise due to various reasons which are not necessarily separate. Bias in machine learning refers to both the error introduced by model assumptions and the systematic distortions in data. What are support vectors in SVM? A support vector machine SVM is an algorithm that aims to place a line or plane or a hyperplane between various classes in a way that maximizes the distance from the line to the point that belongs to each class. In this manner, it aims to establish a strong differentiation between the classes. The support vectors represents the points located at the edge of dividing hyperplane. What is neural network? A neural network in machine learning is a computational model inspired by the biological neural networks in the human brain. It is a powerful class of algorithms used for tasks such as classification, regression, image recognition, natural language processing, and more. Neural networks are especially well suited for complex tasks where traditional machine learning models may struggle, such as pattern recognition, speech, and image processing. How do you make sure which machine learning algorithm to use? A software prototype is a functional model with restricted capabilities. The prototype may or may not embody the precise logic utilized in the ultimate software program. Hence, it constitutes an additional task that ought to be factored into the overall calculation. Users have the opportunity to evaluate developer proposals and test them prior to implementation through prototyping. It also aids in understanding user-specific details that might have been overlooked by developer during product development. POC, proof of concept, serves as valuable approach for organization to confirm the feasibility of an idea or concept. What is cross-validation? Cross-validation is a technique that involves dividing your data into three parts: training, testing, and validation data. The data is divided into k subsets and the model is trained on k1 of those datasets. The final subset is reserved for testing. This process is carried out for every subset. This is k-fold cross-validation. At last, the scores from all k-folds are averaged to generate the ultimate score. What are some real-life applications of clustering algorithms? Clustering techniques can be applied in various areas of data science, such as image classification, customer segmentation, and recommendation engines. One of the most common applications is in market research and customer segmentation, which is then used to target a specific market group in order to enhance business growth and profitability. What is future engineering? How does it affect the model's performance? Future engineering involves creating additional features based on existing ones. At times, a delicate mathematical relationship exists between certain features. When thoroughly explored, new features can be created using these mathematical operations. At times, several pieces of information may be combined and presented within a single data column. During these moments, creating new features and utilizing them allow us to delve into data more profoundly. If the derived features are significant, they greatly enhance the model's performance. What does a hypothesis signify in machine learning? A hypothesis is a concept typically employed within the domain of supervised machine learning. We have independent features and target variables. We aim to discover an approximate function mapping from the future space to target variable. This approximation of mapping is commonly referred to as hypothesis. How to measure the effectiveness of the clusters? To assess the effectiveness of the clusters, various metrics can be used such as inertia or sum of squared errors. Among these metrics, the inertia or sum of squared errors and Silhouette score are common methods for assessing the effectiveness of clusters. Also, although this approach may incur higher computational expenses, it is undeniably effective. The score is high if the clusters formed are dense and well separated. What is overfitting in machine learning and how can it be avoided? Overfitting occurs when the model not only guesses patterns but also picks up on the noise within the data. As a result, it performs exceedingly well on the training data but falters when presented with new unseen data. To prevent overfitting, various methods can be employed. One approach is early stopping during model training. This technique involves halting the training process when the validation performance fleets. Even as the model continues to learn, regularization methods such as L1 or L2 regularization are utilized to penalize the weights of the model, preventing overfitting. What is the reason behind opting for smaller values of learning rate? Smaller values of the learning rate facilitate the training process to coverage converge gradually towards the global optimum rather than oscillating around it. A smaller learning rate leads to more incremental adjustments to the model weights, enhancing the precision and stability of the updates. If the learning rate is set too high, it may lead to the model weights updating too rapidly, potentially causing the training process to overshoot the global optimum and ultimately fail to coverage. To prevent error value oscillation and obtain the optimal weight for the model, it is essential to employ lower learning rate values. What separates upsampling from downsampling? When using the upsampling technique, we augment the quality of samples in the underrepresented class by randomly choosing certain points from the class and integrating them into the dataset. This operation is iterated until the dataset achieves equilibrium across all classes. But there is a downside of this. The training accuracy consistently increases as the model is trained multiple times within each loop. On the other hand, this same level of accuracy is not reflected in the validation accuracy. In the scenario of downsampling, we reduce the number of samples in the majority class by randomly selecting a quantity equivalent to the number of data points in the minority class. This action aims to balance out the distribution. In this scenario, we may experience data loss, potentially resulting in the loss of important information. What does one-shot learning mean? One-shot learning refers to a machine learning approach in which the model learns to identify patterns in data sets using only one example rather than relying on extensive data sets for training. This is helpful when we don't have extensive data sets. It is used to identify the similarities and differences between the two images. What distinguishes covariance from correlations? As indicated by its name, covariance offers a metric for the degree to which two variables differ from one another. However, correlation provides us with a measure of how much the two variables are associated with each other. Covariance can have any value, whereas correlation ranges from -1 to 1. These techniques are employed in exploratory data analysis to extract insights from the data. What distinguishes one-hot encoding from ordinal encoding? One-hot encoding and ordinal encoding are distinct techniques for transforming categorical features into numeric formats, with the main difference lying in their implementation methods. In one-hot coding, a distinct column is generated for each category, assigning either 0 or 1 based on the value related to that row. In contrast to one-hot encoding, Ordinal encoding involves substituting the categories with numeric values ranging from 0 to n minus 1, determined by their order or rank, where n represents the total count of distinct categories in the dataset. How can you determine the effectiveness of the model using the confusion matrix? A confusion matrix provides a summary of how well a classification model performs. In a confusion matrix, we obtain four kinds of outputs for a binary classification problem, which are TP, TN, FP, and FN. It is understood that square has two possible diagonals, and one of these diagonals correspond to the numbers where the predictions of our model match the actual labels. Our aim is also to enhance the values along with these diagonals. Using the confusion matrix, we can derive different evaluation metrics such as accuracy, precision, recall, F1 score, and more. What purpose does the violin plot serve? The term violin plot comes from the graph shape that resembles a violin. This chart expands upon the kernel density plot while incorporating the characteristics of the box plot. All the statistical measures represented in a box plot are also displayed in the violin plot. However, the width of the violin indicates the density of the variable across various value regions. This visualization tool is typically utilized during the exploratory data analysis phase to examine the distribution of continuous data variables. In doing so, we have addressed several key machine learning concepts that interviewers typically inquire about to assess a candidate's technical comprehension. Additionally, we wish you best of luck in your in your upcoming interviews. Distinguish stochastic gradient descent from gradient descent. In the gradient descent algorithm, we train our model on the entire dataset simultaneously. In stochastic gradient descent, the model is trained using a mini batch of training data simultaneously. When utilizing SGD, one shouldn't anticipate a gradual decrease in training error. The training error fluctuates, yet after several training steps, we can conclude that it has decreased. Furthermore, the minima obtained from employing GD might differ from the reached through SGD. It has been noted that minima obtained with SGD are near to those of GD but not identical. If you need further help in interview preparations or if you need further help in job support, internship, need real time project experience, or if you need any help in building CV, please contact customer care at jobconquest.com. Follow us on Instagram, jobconquest25. Thank you.